When it comes to IoT mesh networks, what do you think is the most important design concern to keep in mind? That it works? Well, sure, but I was thinking beyond that. I'd say that it's scalable, but scalable without adding too much cost to your infrastructure bottom line. One of the most important aspects of these kinds of designs, where battery powered nodes reign supreme, is making sure your recurring costs don't get out of control. And depending on the kind of IoT network you need, well, that's where cellular networks may not be the best bet. For a lot of large scale industrial IoT networks, Wi-Sun may be the best way to go. And folks, that's exactly what we're talking about today. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Quinn Jones from Digi, Chad Steider from Silicon Labs, and I explore how Wi-Sun micro mesh can reduce cost and simplify development for your next IoT mesh network. We also investigate the benefits that Digi XBee Solutions brings to these types of networks and how you can jumpstart your next IoT mesh network design with Silicon Labs and Digi. And before we get started, don't forget to click that link. There you can find even more information about this topic. Hi, Quinn. Thank you so much for joining me.
Thank you. Good to be here.
And hi, Chad. Thank you for joining me.
My pleasure.
Okay, so Chad, we're talking all about how we can design scalable IoT mesh networks with Digi XBee for Wi-Sun today. But before we get started, give us some information about Wi-Sun.
Wi-Sun is a standards-based LPWAN technology built on the 802.15.4G standard, which ensures global interoperability, reduces vendor lock-in, and provides a pretty simple certification process. Wi-Sun is governed by the Wi-Sun Alliance, which is backed by a strong ecosystem of utilities and vendors, really driving open standards and long-term network evolution. It's set up for both line and battery-powered devices, so it supports hybrid deployments from grid-powered routers to low-power sensors, really allowing you to optimize for the network that you want to deploy rather than forcing you to compromise for power or performance or any of those other network parameters that we see. It is a self-forming, self-healing mesh topology. So it maintains connectivity automatically by rerouting data through alternate nodes if a node does go down to give you maximum uptime. It is a network designed with security in mind. So it uses advanced encryption, mutual authentication, and really tries to mitigate cyber threats and ensure data integrity across the entire network. And then it's highly scalable. There are deployed Wi-Sun networks that have, tens of thousands of nodes on them, or it can scale down to, 50, 100 node networks, depending on what your needs are. So it really is truly a very flexible network for long range applications.
Excellent. Now, Chad, talk to me about the positioning elements here.
Yeah, so when you look at the sub-gig space in general, one of the biggest questions that I get from customers is, okay, like there's so many options, which ones do I choose? And each of these different networks on this slide really have a different place in the market. So when you're talking about very, very long range, very low data rate, that's where something like LoRa or even Z-Wave comes into play, depending on which segment of the market you want to play. And then if you need a little more data rate, you can scale up to something like Amazon Sidewalk, or I've put NR Plus on here, even though it is, 1.9 gigahertz, but it fits in the same kind of LPWAN technology space. But when you look at Wi-Sun, you get a really good compromise of data rate and range. So Wi-Sun supports, the standard supports up to 2.4 megabits per second today, but it should be expanding to 3.6 megabits per second while giving you that kind of citywide coverage with long range, scalability, and IPv6 addressability to each individual node. At the high end of the data rate side, we have Wi-Fi Halo, but that's really a star topology network, so a little different than what we're talking about with Wi-Sun.
So, Chad, I've been hearing a lot about FAN 1.1 lately. Let's talk about that as well.
Yeah, so Wi-Fi has been around for a long time, and that first initial implementation was FAN 1.0. We've been talking about FAN 1.1 for the last couple years, but it now is to a point where almost all of the features in FAN.1 have been rolled out and are certifiable. FAN 1.1 is an extension of FAN 1.0 meant to add higher data rates and low power nodes. So it keeps what made Wi-Fi what it is at the heart of the network but expands upon that. So with FAN 1.1, we get kind of three pieces as part of it. You get FAN 1.1 core, which is really just extending existing FAN 1.0 networks to be able to add some of this 1.1 functionality. Then you get FAN 1.1 high performance, which introduces those high data rate Sun OFDM PHYs. Again, high data rate up to 2.4 megabit per second. It gets you some additional multipath immunity, and it introduces mode switch as well, which allows you to switch between OFDM and FSK PHYs or even different data rates within the same modulation. And lastly, we get FAN 1.1 low energy, which brings Wi-Sun to battery powered nodes. When you're talking about the high performance and even the 1.1 core, all of those nodes are going to be routing nodes. They're going to be, responsible for not just their data, but the data of the nodes that they're connected to. The LE option makes those nodes endpoints on the network. So they're not routing nodes. You're able to optimize for the lowest data rate and longest battery life you possibly can to really meet those applications where Wi-Sun maybe wasn't a great fit in the past.
You mentioned limited function nodes just now. Can you walk me through what all those include?
Yeah, so when we think limited function node or low energy node, we're really talking about battery powered applications. So these are, nodes that are transmitting maybe 1 to 2 kilobytes of data per day with the goal of getting 20 years of battery life on these type of 2 amp hour batteries. These nodes cannot be routers, so it's limited to what we call leaf nodes. There is an LFN parenting feature that's required on the router to support LFN children. Each LFN is paired to a full function node, and then that full function node buffers the messages and send them to the LFN nodes when they wake up and are ready for data. Now, from Silicon Labs, we support LFN on both our EFR32, FG28, and 25 platforms. So really, if you need kind of higher data rate applications, you can use FG25, or lowest power, you can use FG28.
What benefits does Wi-Sun bring to the table versus cellular networks?
I think there are a couple different ways to look at this. When you look at the large scale mesh networks that have previously been deployed, you're really only having to deploy one cellular based connection per 2000 plus nodes. So when you look at how to deploy the same number of nodes within a cellular network, each one of those is going to have, a license cost. They're going to have a recurring cost. With Wi-Sun, you can really bury that recurring cost in one gateway and scale that network immensely. Now, that does require some careful network planning to get up to those large pan sizes, but it comes at the trade-off of, you don't have sunset issues, and you're really only having to carry the cost of that cellular connection and the infrastructure once per pan. Now, what we're seeing is really the emergence of Wi-Sun as a micro mesh. This is a use case that's really interesting, and it is really expanding beyond metering and streetlights and industrial automation, where we've seen Wi-Sun have such a big foothold. What we're talking about with these are kind of 10 to 100 or 200 node networks where you can use a very simple border router so that infrastructure cost goes down significantly. In a lot of cases, you can talk, a small A class or even an M class type processor in the gateway to manage these networks. They're really simple to set up and deploy. It's got low infrastructure cost and low recurring cost. And, unlike cellular, you don't have the sunset concerns that you do where, if the technology goes away, I've got to go back and retrofit every node in the network instead of potentially just one border router node.
That makes sense. So, what kind of use cases are we really looking at here?
Really, the emergence of micromesh has been driven by, commercial HVAC, commercial inverters, and solar farms. Some of those distributed energy resource type networks, and agriculture. So when you think about a big commercial building that may have multiple rooftop HVAC units, multiple zones that it needs to control, you can set that up with YSUN and you get the advantage of the IPv6 addressability to each node. You have the sub-gig robustness in the buildings and the scalability of YSUN if you want to start adding sensors or other environmental monitoring equipment throughout the building. On the inverter side or solar farm or distributed resource side, same kind of setup. You have all of these different systems that are out in the field and being deployed. And if I have to bury cellular connectivity into each one of these, it gets really cost prohibitive. But, again, I can use one simple border router in an installation, put a YSUN connection in each of these nodes and really expand that quickly while also giving me the ability to add an additional PAN or additional micro mesh as that resource grows. And same thing with agriculture and irrigation, right? These are nodes that are sometimes half a mile to a mile apart. So you need the long range of sub gig, but you don't want to have to carry the cost of a cellular connection in each of these nodes because, frankly, a lot of them are use once type nodes. So if I've got a cellular radio and have a connection to each node and then it gets destroyed, that's a pretty heavy cost burden for the folks that are installing these systems, where with YSUN, it's a much lower upfront cost and you don't have to manage the recurring costs as well.
All right, so let's bring in Quinn and talk about Digi XBee for YSUN.
Yeah, great. So yeah, Chad definitely gave us a lot of information on YSUN, and we're excited about the Digi and Silicon Labs partnership to develop a YSUN solution. So just to kind of summarize, what Chad has kind of covered here, yeah, we're excited because YSUN gives us the ability to move kind of the next level with an open standard protocol. So we have interoperability here. We have the YSUN Alliance, which you mentioned, with that sub-gigahertz range, IPv6 security, all these benefits. It just opens the doors to a lot of different applications. It's also very proven, and I'll talk about that in more detail. But what's exciting is Digi's offering not just a component of the solution, but the full solution. So the modules, the border router, and our management tools.
Quinn, the scalability aspect of this solution is very important given the number of connected devices worldwide, right?
Correct, yes. When you look at some of the examples of where YSUN has been used and the numbers, the scalability, it's very exciting. It's massive, as you've said. So TEPCO in Japan has a network of right around 30 million smart meters processing about 1.5 billion data packets daily. So lots of meters, lots of connectivity there, and lots of data going through those. City of London has a streetlight network with 15,000 nodes in it. Interestingly, this has 12 border routers in the network. They saw a huge energy savings after their deployment. And then two other fun examples, City of Miami and Paris both have streetlight networks running with YSUN. Miami has a backbone of metering networks that the streetlights are using to communicate on. So 500,000 streetlights in Miami and then 280,000 in Paris. And again, just seeing a lot of benefits from the YSUN network and cost savings, which is exciting because, huge networks, and now we're getting to see how that rolls out for other types of applications.
What's all included in Digi XBee for YSUN?
With our XBee for YSUN solution, we have our modules, our XBee modules that support the different YSUN protocols or options, and I'll explain those in more detail. We have our border router, our XBee High border router, and then our tools for both local development as well as remote management.
So, Quinn, walk me through each aspect of this solution. Let's start with the nodes.
So in this diagram, I have a picture of some different nodes communicating with the border router. So I've tried to just represent, we have some limited function nodes and full function nodes, which we'll talk about in more detail, but this network could be all full function nodes. It could be all limited function nodes. Here I was just trying to show an example of what it could be, but keep in mind that this could be a mixture of those different node types.
So talk to me a bit about FFN node and LFN node. How do they differ?
So Chad mentioned the Silicon Labs FG25 and FG28. So we have developed some XBee modules based on those different chipsets. So the FG25 version is the full function node. It does support LFN, as Chad mentioned. The exciting thing about this is the FFN node is a routing node essentially and supports both FSK and OFDM data rates. And then we've added on top of that the ability to add MicroPython scripts. So it gives you the ability to customize the module based on your needs. And then on the LFN side, we have an FG28 version. So leaf nodes, this supports only FSK data rates. And we're adding Bluetooth low energy to this as well. And this is the node that can give you the better battery life. So, years of battery life with this. And then we've also added the MicroPython capabilities to this module as well.
Okay, so Quinn, what kind of features are we talking about for the Digi XBee for Wi-Sun?
So Chad spoke about the different fan options. So we are certifying our XBee for Wi-Sun modules with the fan 1.1. We're also coming out of the chute certifying our product in US, Canada, Europe, India, and Japan. We support the different power levels in those different regions, as well as different antenna options just to help customers depending on their needs with their products. It gives you all the flexibility of an XBee module when you're designing in, adding that to your product, giving you the fan options with the Wi-Sun protocol.
Okay, so can we also talk about the Hive border router you mentioned earlier?
Yes, and that is an essential piece of the puzzle here. So we've got the modules, and then you need a border router, right? So yeah, let's jump right into it. The border router, so we have it both in a bare PCB version and also an enclosed version, or the product in an enclosure. So this has our Digi Remote Manager fully integrated. I'll talk more about that in a minute. This is a platform that it runs a dual Cortex A7 processor, so lots of horsepower. As well, we support Linux containers and Python, so lots of customability available on the product, and full routing capabilities as well, including IPv6 to v4 translation, which is very unique. So trying to take away some of the headaches that developers have when they're creating a Wi-Sun network. And then on the backhaul options, we have cellular. Right now it's Cat1, and then also Wi-Fi, Ethernet, Bluetooth options. So a lot of flexibility with this platform.
It seems like it. Now, Quinn, we have talked about Digi XBee Global Connect on a previous Chalk Talk, and that solution is also included here as well, right?
That's correct. Yeah. So to make things easy, the thought was that, when a customer gets one of the border routers, instead of having to try to figure out what carrier would work with it, and maybe they have a relationship with the carrier, maybe they don't. Instead, we decided just to make this kind of foolproof or seamless. So we are including a SIM pre-inserted in the device that allows you to get up and running quickly. So it gives you 500 megabits of cellular data over a 12-month period of time. Idea, again, is just to make it simple and easy so you can evaluate quickly and get to market quickly.
So when it comes to IoT designs, Digi has a complete solution that includes devices, software, and services, right?
Yeah, correct. In fact, we've added, as part of the solution on the border router, we've added our Digi 360, which covers the warranty, customer support, and device management. So we're, again, trying to help you get to market quick and cover all the aspects of the solution.
Quinn, how does Digi Remote Manager work when it comes to Wi-Sun?
Our Digi Remote Manager is a kind of what it sounds like. It's a remote management platform. This allows you to send firmware updates to devices or networks in the field. And when it comes to Wi-Sun, that's exactly what you need. When you have a remote network out in the field, or remote networks across the country or across the globe, this gives you the ability to manage the devices in the field. And it's also SOC 2 Type 2 verified, which just shows that it's proven and secure.
So walk me through some of the features and use cases for Digi Remote Manager.
Yeah, so I briefly talked about one, just the firmware updates. And this is very unique and helpful if you have, again, networks in the field where you want to upgrade firmware, maybe individually or in batches. This gives you a tool that allows you to do that. It also helps you with compliance with security. It gives you the ability to update files on the devices. So if you're running Python or those Linux containers, files in Linux containers, gives you the ability to update those. So the idea is just, again, that remote management aspect, and it's all under one view or one pane of glass to help you manage devices around the world.
So what about Digi XBee Studio? What kind of features are we looking at here?
Yeah, so XBee Studio, our Digi XBee Studio is our platform for local configuration. So we've had this around for years, and it works with our other protocols. And so we've added Wi-Sun support on it. So this gives you the ability to do some fun things like when you get a development kit, there's some quick setup options. So you can do some testing and pull in nodes and see them join the border router. It allows you to look at the network live, and you can see, what the receive strength looks like between nodes. All the functionality built into XBee Studio, but now supporting Wi-Sun. Test and get to market quickly with your devices and solution.
Fantastic. Okay, so Quinn, let's also talk about some use cases for this solution. Now, I would imagine that smart cities and energy markets would be a good fit here.
Yeah, exactly. Kind of covering the same markets that Chad discussed. When we look at where use cases for Wi-Sun fit especially well with our XBee solutions, we see the energy vertical, smart cities, agriculture, and industrial. I'll talk about some examples in more detail, but you think renewable energy with solar fields, large solar fields, smart cities with street lighting, which I mentioned briefly, agriculture, the irrigation and monitoring aspects, and then all sorts of different IoT applications.
Okay, so Quinn, what would this look like for an EV charging application?
This is one I really like. When you think of EV charging, you think of these multi-level parking facilities. It's a rough RF environment. You've got the cement from the walls, you've got vehicles coming in and out, your RF paths are changing constantly. And this is where a mesh network, especially like Wi-Sun, comes in very useful as a perfect application for it. So your nodes can send the data from node to node in a mesh network until they reach the border router, and then backhaul that data into your management platform.
So, what about a smart cities application? Can you walk me through what that would look like as well?
So this is the application I mentioned briefly about the city of Miami and city of Paris, city of London, where they have streetlights enabled with Wi-Sun. And streetlights, it's a great application for a mesh network and Wi-Sun. So the nodes are typically placed high in the air. You think of height of a street light, and that's great for maximizing the RF range of the devices. And so add a mesh network to that where they're hopping from node to node throughout a city, gives you just incredible coverage. And then add the border router to backhaul that data. And again, like those examples I mentioned, you can cover large cities.
So, what about those utility mesh networks you mentioned earlier? What would that look like?
There's kind of a mix of things here. You've got the renewable energy applications where you have solar fields. You think of miles of solar fields covered by Wi-Sun, where the data can repeat from node to node till it reaches the destination or the border router. You add street lighting into that application and even the meters. It's a real comprehensive solution for utilities to allow communication on all their different devices.
So, do you have any other interesting use cases you can share?
Yeah, just kind of highlight some of that I talked about. The City of London, 15,000 connected Wi-Sun devices with 12 border routers. Again, this was focused on street lighting, but now they're starting to add different sensor applications or sensor devices to that network. Environmental monitoring is the goal of that application. So kind of unique in that it started lighting, but they're starting to add different sensor inputs to that network. And then the City of Paris, exciting one where it's 280,000 LED-based streetlights. They rolled this out and saw a 70% savings in annual costs. So next time you're in Paris, you'll have to take a look at the streetlights. Same with the city of Miami. They've got a 5 million meter network running Wi-Sun and then added the streetlights to that network. So they were excited about this because, that meant fewer truck rolls. They have visibility to the devices to see if they're online or see if they've failed or know when maintenance is needed. And it's also acting as a canopy for other IoT sensors. Again, similar to the City of London, where they're looking at adding environmental sensors, parking, traffic, all sorts of different options there.
Okay, so Quinn, for my audience who wants to get started using these solutions for their next design, what should they keep in mind?
With our XBee solutions, it's a platform that offers a variety of different protocol support, but it's not just a module, it's an ecosystem. We started with 2.4 gigahertz or short range mesh. We've added sub gigahertz. We have cellular, LoRaWAN, all sorts of different protocols here, but we've also added the libraries, the APIs, everything to make it easy and simple for you to get to market quick. It's a proven platform with over 25 million modules deployed globally.
So, Quinn, what specific solutions should my audience explore to get started?
I would recommend, you started with a development kit. We'll talk about that in just a minute, but this gives you the ability to test the modules, the border router, and the management platform along with the tools so that you can set up a Wi-Sun network and get to market quick.
All right. And Digi also offers a YSUN development kit, right?
Yeah, correct. And that's what I was referring to, that I would recommend those that are interested. This development kit allows you to have some nodes that can join a border router. So you can do different things like look at the throughput, look at the range, look at your different antenna placements on the device and how that'll impact range. It also gives you the Digi Remote Manager trial account and the tools needed so that you can start testing and get your product to market. Yeah, and then finally, we have added our Digi XBee Global Connect to the development kit as well, so that you have the ability to just plug in the border router, have it start working, sending the data where you need it to. So trying to take away the hassle of finding connectivity, cellular connectivity on the development kit.
Fantastic. Well, I think that's all I have time for today. Thank you so much for joining me, Quinn.
Thank you. Thanks for your time.
And thank you for joining me, Chad.
Thank you.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.